So let us start with the next subtopic of our syllabus, that is non-homogeneous non-homogeneous second order linear differential equations with constant coefficient. Linear Now, second order linear differential equations, with constant coefficients. Okay. So previously we had studied was only homogeneous differential equations with constant coefficients, right? So now we are talking of non-homogeneous, right? So basically what we are doing is we are considering equations of the form y double prime, a y double prime plus b y prime plus c y is equal to r of x. Okay, where a, b, c are constants and r of x is a function of x. Okay, where r of x is a function of x. So now, in all the previous problems which we have studied for the last 2 weeks now, the r of x is taken to be equal to 0. Okay, where r of x is a function of x and r of x is not equal to 0. Okay, it is not identically equal to 0. It can take the value 0 somewhere in between, like sin x becomes 0 somewhere, right? Cos x also becomes 0 somewhere. But it should not be the entirely 0 function. So I'm writing 3 equal to sin x. Okay. Yeah. So now there are various methods to solve this thing. We'll be studying all of them. So methods to solve this expression. Methods which you will be learning. So one is very undetermined coefficients. Variation of parameters. And the third one is something called as a D operator method. Fourth one is using one solution. So we are given one solution of the differential equation. You can use that one solution and find more solutions of it. Using one solution to find another solution. Okay, so these 4 methods will be covering up over here in this course. There are many more methods. We will be studying only this 4 in this paper. Okay. Okay, so let us start with the first method, that is method of undetermined coefficients. Method of undetermined. Yeah, before I start this method, no, there is something which I have to say in general. Just write this on before we start. I'll write on this page only. Note one very important note. This is important note. For homogeneous equations, for homogeneous equations, equation a y double prime if y of x y naught is a solution. Okay, if you have a solution of the homogeneous equation, then any scalar multiple of this any scalar multiple of this is also a solution for alpha belonging to set of real numbers. Okay, you multiply your solution with any constant, you get another solution of it. Okay, it need not be a completely different solution, but it's another new solution there, right? This need not be true for. This is not true for. Yeah, by the way, how do I know that this is the solution? If you substitute it in this, it will still be, the equation still becomes true. Just substitute this alpha y naught in this. What will get? You get a times alpha, times y double prime y naught of x plus b times alpha y naught prime of x, right? Plus c times alpha y naught prime of x. Alpha is common in all three terms, right? So you can remove it and cancel it out. What remains over there is going to be a y double prime, a y naught double prime, b y naught prime, and c y naught. And we already know that y naught is the solution, right? So LHS will be equal to RHS. Both will be 0. Okay? You can verify this now, that this will be a solution. We have done this before. to it. This is not true for non-homogeneous equations. This is not true for non-homogeneous equations. Not true for non-homogeneous equations. You can easily check if you are given. It's not true for non-homogeneous equations. If y1 of x is a solution of a y double prime plus b y prime plus c y is equal to r of x, then consider y2 of x to be equal to some scalar multiple alpha times y1 of x. Okay, then substitute this here, a y2 double prime y2 double prime plus b y2 prime plus c y2 prime, right? What will this be equal to? This will become a times alpha y1 double prime plus b times alpha y1 prime plus c times alpha y2 alpha y1. But here you can take this expression common, alpha y1 prime plus c y1. Okay, this is what you get. But this you know is equal to r of x, because y1 of x is the solution. This thing will have to be equal to r of x. Okay. So your LHS turns out to be this. Your LHS is equal to this. RHS is going to be equal to r of x only. Okay. So you see that LHS is not equal to RHS. Hence, okay, hence y2 of x is not a solution. Not a solution of the given given differential equation. Okay. So for homogeneous case, you could just multiply the equation with the scalar and you got another solution. Okay, need not be an independent solution, because the solution will be just a scalar multiple of the original one, right? But here we don't even have that option. Once you are non-homogeneous, you get RHS starts creating problems over here. See, if r of x was equal to 0, then LHS becomes equal to RHS. No? Right now, but you have assumed r of x is not equal to 0, so there has been no problem here. Constants are not getting eliminated. Okay, so yeah, so let us go to this method now. Method of undetermined coefficients. Okay, so here in this method, what do you mean by undetermined coefficients? Basically, there are some unknown coefficients over here which you have to find out. Okay, so basically, in this method, we try to guess the solution. Try to guess the solution. So there are cases which arise here. Case 1, r of x is a polynomial okay. So we will have cases. Now I'm starting with the polynomial case. After this we'll see exponential case and then trigonometric functions. Okay. So in every problem sessions now we'll be dealing with these three cases separately: polynomials, trigonometrics, and exponential functions. Okay. So we'll start with polynomial because they're always easy. So let yp of x be equal to alpha plus beta of x gamma of x square. Okay. Be the particular solution of the differential equation. Why subscript p? It's called as the particular integral or particular solution. It's also called as the particular integral. Okay, short form, we call it as PI. Where alpha, beta, gamma are known constants to be determined. Constants to be okay, where alpha, beta, gamma are unknown constants which we have to find. Yes, writing. Right. So let us work this out with the help of an example. Uh, example. By the way, if you had a this thing, wait. If Rx is a polynomial of degree n, no, this will have to continue up till gamma beta. The nth alphabet I think so is this in the Greek, this thing. Okay, x raised to n. This said this one more term, no? I wrote it up till x square by mistake. It has to be written up till degree n. No? Some alphabet will put. I have written eta over here. Okay. Yeah. So example. So first one, given the equation is y double prime minus 2y prime plus 5y, y double prime minus 2y prime plus 5y, 25 x square Okay, so how to solve this equation is, there are two parts. Solution. Okay, there are two parts involved here. The general solution. General solution of the above D will be of the form y of x is equal to yc of x plus yt of x. Okay, where yc of x is the solution of ay double prime plus by prime plus cy is equal to 0. Okay, so it is the solution which you get by equating this LHS equal to 0. Okay, equate the LHS equal to 0 make it equal to 0 and solve it. What you get over there, this is called a YC, okay, and it is called the complementary function. Complementary. Okay, this is called as the complementary function. Okay, complementary. Just complement and just write array over there. Okay, it's called a complementary function. Okay, we know how to find YC, right? That's what we have done so far in this chapter, right? Just find the auxiliary equation and equate it to 0 and etc. etc. Okay, and YP is called as the YP of X is called a particular integral. Okay, YP is called as the particular integral. So now let us solve the given differential equation. We are given y double prime minus 2y prime plus 5y is equal to 25x square plus 12. Okay, so consider first you equate it to 0 and you solve it, and then we solve the RHS separately. So this part we know how to do, so we'll start doing this one. Consider the LHS equal to 0. Okay, so the corresponding auxiliary equation will become, the auxiliary equation is, I'm using the alphabet R, right? R square minus 2R plus 5 is equal to 0. Okay, so what do we get here? R is going to be equal to plus 2 D square 4 minus 4AC, so minus 20 upon 2 plus or minus root 16 will come, which will become 4i upon 2. So this will become 1 plus or minus 2i. Okay, so see, last time we used to call the solution after this particular step, whatever we get, we used to call that solution as the general solution. But now we can't call it a general solution because there's one more term to be added over there. So what we'll call this as the complementary function. Okay, so thus the complementary function I'll refer to this as just CF in the subsequent videos, is y of c of x, which is going to become, what is this going to be? E raised to x a times cos of 2x plus b times 2x. This is the complementary function. Okay. Now what is remaining to be found is the yp, the particular integral. Okay. Who's writing this now? Yeah, so this is a what degree polynomial you have. Let yp be equal to, we'll start with a second degree polynomial. Okay, start with a second degree polynomial because you were given a second degree polynomial as r of x. Okay, so let yp be this be the particular integral we'll be calling it as PI in the subsequent videos. Okay, I won't write such a big name, I'll just write PI. Okay, let this be the particular integral. So now this has to satisfy the given differential equation, right? So what will be yp prime? This will become beta plus 2 gamma of x, and yp double prime of x will be equal to just 2 gamma, right? So now substitute this in. So what is your given differential equation? Y double prime minus 2y prime plus 5y equal to okay, substitute here. So this will become 2 gamma, this will become 2 into beta plus 2 gamma x, okay, and this will become 5 times alpha plus beta x plus gamma x square. This is equal to 25x square plus 12. Okay. Clear? So now collect the terms with the like powers together. So you will be getting a collecting terms together of same degree five gamma okay. Who's going to contribute to the x term? We have 5 beta minus 4 gamma five alpha minus 2 beta okay. This is what I will get. Correct it is no? Just check. Correct now? Expression. So now what you will do next is compare the coefficients on both sides. Where there is x square here, you compare it with x square over here. Where there is x over there, you compare it with x over here. And then for the constant, you compare it with constant. Okay, so comparing the degrees. Comparing the degrees of x. So you'll end up with 5 gamma is equal to 25 0. This is for x square, for x is to 1, and this is for x is to 0. So who is the coefficient of x on this side? It is 5 beta minus 4 gamma, Here you will be having 5 times alpha minus 2 beta plus 2 gamma. Okay. Now to solve the 3 equations and 3 variables. We have not done it so far in basic algebra. Okay. Anyways, this is a nice thing because you don't have to worry much here. You have 5 alpha is equal to 5 gamma is equal to 25. So what will be gamma? Gamma has to be 5. Take that value, substitute in the next equation. You get the value of beta. So now you have beta and gamma. Substitute them in the third equation. You will get the value of alpha. Okay. So this is the easy expression. Otherwise, you will have to learn some techniques of how to solve it. Okay. But anyways, before our final exam, you all will be learning it in the other paper. So yeah. So just calculate and tell me what will be the numbers. My page is over here. Gamma I calculated equal to 5. Substitute here, this will become 4 into 5 will be 20, take 20 on this side. So beta has to be equal to 4, right? Then what do you have here? Five alpha is equal to minus 2, this will become 8, and plus 2 will become 10 is equal to 12. So this will become 5 alpha plus 2 is equal to 12. So 5 alpha is equal to 10. Alpha is equal to 2. Yeah, correct everyone? 2, 4 and 5 I got. Okay. So hence, I'll just write here. Okay, so hence yp of x is equal to substitute the values. Alpha we got equal to 2, beta we had equal to 4, and this we had got equal to 5. Okay. This is your particular integral. Okay. Thus the general solution is y of x is equal to e raised to x a times cos of 2x plus b times okay. So this is your solution. Okay, got it. So we'll just solve one more problem and stop on this kind. We'll do the other cases next time. Finish writing. So general solution is yc plus yp. Huh? Okay, so let's try to do it fast. There are only 5 minutes. So second example of this type, y double prime plus y prime is equal to 10x raised to 4 plus 2. Okay. So first I'll consider this expression y double prime plus y prime is equal to 0 The corresponding auxiliary equation will be r square plus r is equal to 0. So this will leave you with r is equal to 0 or r is equal to minus 1. Okay. So thus your solution is the complementary function. The complementary function is given by yc of x. That's going to become c1 e raised to 0x plus c2 e raised to minus x. The solution becomes c1 plus c2 e raised to minus x. Okay. This is the solution of this expression. Okay. So now we have a degree 4 polynomial here, right? So let see r of x is degree 4 over there, degree 4 polynomial, right? So we write let r of x be equal to alpha plus beta x plus gamma x square plus delta x cube. The next alphabet is called epsilon. Yeah, if I don't know Greek alphabet, so you can just write ABC. No harm in that. Okay, this is what you'll get. Sorry, not r of x. Sorry. Let yp of x be equal to this. Just change it up. Let yp of x be equal to this. Okay, so what will be your yp prime? This will become beta plus 2 gamma of x plus 3 delta of x square plus 4 epsilon x cube, and y double prime y double prime p of x, yp double prime of x. That's the better way. This will become equal to 2 gamma 6 delta x plus 12 epsilon x square. Okay, so thus substituting in y double prime plus y prime plus 10x raised to 4 plus 2. This will leave you with 2 gamma plus 6 delta x plus 12 epsilon x square beta gamma of x 3 delta of x square 4 epsilon of x cube. This is equal to 10x raised to 4 plus I think so. I'm going to get a problem here. We're going to have a problem here because there's no degree 4 term on the RHS. Sorry, on the LHS. But this on the other side. We'll get 10 equal to 0 here. That can't happen. Wait a minute. It must be modified here. You all understood what is the problem, no? On the LHS, there is no degree 4 term. So when you equate the LHS and RHS, you will be getting 10 is equal to 0. Because there is no degree 4 term on this side. I think so we should have started with Actually, this is a special case problem. Huh? Not be able to solve it like this. You have to make some changes here. Okay. So just leave half a page for this and discuss it in the next class, huh? Because there's some special thing to be done here. Okay. So we'll discuss it in the next class and then go ahead. Okay, so we'll stop with this.